Dear all, welcome to our last meeting of this winter semester 2024. Before we start today's lecture, I would like to thank everyone who participated in the LMS Center, either as speakers or as people in the audience. I'm glad that you are interested in our program because it's nice to come together on philosophical topics, and also because it's a good trend for the future that the activities of the LMS Center are worthwhile. Our guest today is Dr. Benjamin Purzycki from Department of Study of Religion at the University of Aarhus. And his topic today is ethnographic free listing, measuring and incorporating culture in the social sciences. Mr. Purzycki, I welcome you to the LMS Center. I'm glad you have joined us near the end of the semester. And now it's time to give you the floor.
Great. Thanks a lot for having me. It's pretty cool to be talking about this topic to philosophers, and it's a diverse field, obviously, but getting some feedback on this particular discussion would be a new angle for me. So I'm excited about that. The talk I'm going to give today is sort of a strange topic, or a strange presentation on an old topic, namely ethnographic free listing. And the reason why it's a little strange is that it's not going to necessarily present a strong argument or test a particular hypothesis, but rather the motivation I have is to sort of promote the cultural sciences, but also promote a method that allows us to tap into properties of culture and cultural information that often get ignored in a wide variety of fields. And so my background is generally cultural anthropology, cognitive anthropology, evolutionary anthropology, and I study religion and cooperation. And so a lot of basic questions that we come into the field with wanting to make sense of, and yet there's so many sort of prefabricated ways to measure things, but we haven't done the sort of prerequisite ethnographic inquiry to design better measures. So this talk is really a way to sort of promote this idea that we can make sense and make better sense of cultural domains using this method. So I'll just profile the method a little bit. It's not going to get too heavy technically, but it'll have some math stuff in it. But it's just a way to illustrate the utility of some of these methods. So let me start my timer here just to make sure I don't get lost. All right. So I can take it away here. It's the cursor here. There we go. So for those of you who sort of have their ears to the ground in terms of social science, culture is making a huge comeback in terms of its significance and utility. It's the appropriateness of various appeals to it or implementations of culture and what that means is often under-examined in my view, but there seems to be some general agreement in terms of what it is that we're referring to when we mean culture. And so we tend to, at least in the cultural evolutionary fields and cognitive anthropological fields, talk about culture as being a measurable, socially transmitted sort of clutch of information. And this information is stored in human minds, and it can vary as such. It can vary between individuals, but also vary between groups. So this idea that culture isn't just everything, it's not behavior, it's not necessarily some ambient, mysterious force that guides our behavior, but rather it's explicitly socially transmitted information. It may turn into deep and hard to measure habits and assumptions, but it nevertheless is transmitted socially. And so as defined this way, it's got some important properties like the content of culture, the stuff that we are conveying to each other. It's got semantic content, it's got rules, it's got structure to it. It also has a distribution. So, we share similar words, we share similar ideas. That suggests that some cultural content is across minds, and it's of course across populations as well. And these transmission streams can winnow and expand and so forth. This idea that this information is socially transmitted and therefore has a distribution, and that distribution itself can be structured in important ways. So you think of like a secret cult or something where only a handful of people who are part of the organization know the secret knowledge, for example. So here's an example of cultural information being structured within subgroups of a population. The important thing about culture, as understood in this way, it also sort of values the fact that culture exhibits considerable variation. But that's within across populations as well. And so this idea that there's some sort of monolithic entity called, for example, Czech culture. I mean, it seems ludicrous in one way, but yet we talk about these sort of monolithic entities quite a bit, knowing that there's considerable variation within that class of organisms. And so these kinds of properties are increasingly utilized and appreciated in the social sciences. And we recognize now, in contrast to perhaps the more nativist turn that happened in the social sciences in the 70s, 80s, and 90s, we're increasingly appreciating culture as important. But at least in my sort of surveying of the fields that I navigate, we all sort of generated this idea that culture might be important, but there's a few ways in which we tend to express this or to emphasize this that sort of lose sight of some aspects of these of the properties of culture that I think are quite important. Take, for example, a Likert scale. So on a scale of 1 to 7, how do you feel about this, or how confident are you in your knowledge of this, or how happy are you about this, and so forth. Or a forced choice type of question like, do you believe in the death and the resurrection of Christ, or something like this, yes or no? These kinds of questions, while they reflect or they might indicate a certain underlying cultural information, they're not necessarily tapping into the aspect of culture. Specifically, I mean, fairly crude way of illustrating this might be to suggest, well, we're not transmitting how to answer Likert scale questions or transmitting how to answer yes or no binary type questions, but rather we have some sort of underlying cultural information that we've been brought up to believe, or we've been brought up to know, or transmitted across peer groups and so forth. And that might influence how we respond to these types of questions. But these types of response options do not tap into directly cultural information, certainly not without these kinds of questions having been validated preemptively in an ethnographically sensitive way. So I'll sort of hint at this possibility in this talk later on. But here's one example of sort of the popular moral foundations surveys created by or composed of a variety of Likert scale type questions. How relevant is, for example, murder to your moral sense or sensibilities? On a scale of 1 to 5, how important or morally relevant is mathematics to your moral sense? So these kinds of questions are prefabricated and placed on these kinds of scales, but very much less work simply asks the question of like what it means to be moral amongst populations, and there we see considerably more variation. So this is a kind of a conundrum that exists in the social sciences as well. There's a considerable amount of behavioral experiments that have been conducted around the world. And the inference that we tend to make is that if there's any variation between groups in behavioral experiments, culture is the culprit. I don't think that's a huge stretch of an inference to make, except that we don't know what it is about the culture that might account for these for variation in these experiments. We don't know if it's beliefs, values. It's just a demonstration that there is between group variation does not really tap into what it is about culture that matters here. So as important as these kinds of experiments are, they don't always really tap into aspects of culture that I emphasized earlier. Same sort of thing as I mentioned before about monolithic characterizations about groups, group level indices like what it means to be a Catholic in Slovakia, for example. It's obviously a complicated topic, but the idea that there's one general group level property that exists that safely characterizes these individuals that fit in that category, or it's obviously fairly crude. So we can do better with that, of course, with individual level data. And as I'll show, free list data is a great way to tap into kinds of things that temper these sorts of generalizations, but also allow us to port them into grander, broader scale comparative type projects. And so I'll make the sort of case, hopefully, is that the free list data, as I talk about it, is a useful companion to the standard kinds of things that we bring into a social science setting, where it's a lab, field work, and so forth. If we value culture and we're interested in particular domains of culture, free list data collection is remarkably useful if underutilized. So this is the thrust of the discussion today. Just to sort of foreshadow what I'll talk about, the free list data and the kinds of things we could do with it can address questions of cultural meaning. So what do people mean when they say some sort of abstract concept? Take the German concept Schadenfreude. We can come up with a nice definition of what it might mean, or what the feeling might feel like. We can describe that. What we can't necessarily do is unpack the cultural model of Schadenfreude without more explicit methods. And free listing is a great example of that, of how we can do that. I'll show you an example in a bit. Free lists can address questions of psychological or cultural salience, meaning like how accessible and potentially important or central to individuals and groups certain aspects of ideas are. As mentioned before, this idea that if we collect this kind of data, we can get the distribution of cultural information and elements of cultural models across minds and across populations. This is one of its central features, actually. And because we're measuring what people think, what people know in the free list, we can get a good sense of cultural variation, again, that's within and between group. And we have all sorts of marvelous metrics by which to measure and quantify cultural variation. If we can do that, we can presumably measure culture and how it changes through time as well. In the burgeoning field, the now mainstream field of cultural evolution, seems to be a primary, a wellspring of ideas that we can apply to making sense of what I'll talk about as being cultural models. So we can measure the evolution, or if we can measure culture, or properties of culture, then we can measure its change as well. We can get a sense of individual and group level knowledge and expertise of particular domains. So we can ask people to list all the animals they can think of, for example, and the length of their list might be indicative of how much they know, but also certain subclasses of information might be indicative of expertise as well. Perception of taste. So this might be thought of as an individual level property rather than a cultural property, but as I'll show you some examples, is that important cross-individual properties of perception and taste can exhibit themselves in free list data. Show some examples of that as well. To mention too, the distribution of cultural information is important, but the structure of those cultural models and cultural representations also have important. Our free list data lends itself to getting a sense of the structure of cultural information, how it's structured within the minds of individuals and populations. So if you're interested in the distribution or the relatedness of certain elements within a cultural model, we can investigate that as well using this data. And the last chunk of the talk will really be addressing, we'll address this issue of context. So if we have a sense of what the cultural models are, what people think and know or believe in their content, in their communities, we can use other variables to contextualize that information. So we can start accounting for variation in those models and variation in psychological and cultural salience of specific items and so forth. So it does lend itself well to the ethnographic enterprise, which is specifically to contextualize the knowledge and activities of human communities and situating them in their place and time. So the outline of the talk will be fairly simple. I'll start off just defining and explaining a basic method of free listing, talk about some content analyses, so what it is that people know and believe and what they think. Structure analyses tell us more about how people think and how they organize the content of their knowledge and beliefs. We'll examine a couple of examples of how domains can overlap with each other. So, how we might think in one area might be related to information in another area as well. But also porting in, refers to or sort of appeals to the context point I made earlier. Is like we can use this kind of free list data in a predictive sort of framework, meaning we can use cultural information to make predictions about other aspects of culture and behavior, but we can also use behaviors and other aspects of society to make predictions about beliefs in the form of this free list data. So I'll take each of these step by step. Right, so here's the basic method. This is what Russ Bernard, methodologist in cultural anthropology, calls a deceptively simple method, and it is quite simple. The goal of free list data is to really to understand what people know, what people think, and the kinds of things that they associate with domains that we're interested in. So common ways to get free lists are as follows. You can say, well, just list any number of items in domain D. So this domain here might be list all the animals you're aware of. And we can see here this data set right here is just composed of two individuals, BGP 001 and 002, and they just list animals, right? You can do this in a constrained fashion. So if you say just list the top 5 things you can think of when I say this, or you can say please list as many, just exhaust your knowledge of this domain. The different ways to ask, solicit this, but at its most basic, free list consists of what people said, who said it, and the order in which they listed things. And I'll show you the order in which people list these things give us some purchase on how we can understand the content and structure of cultural information. So that's the basic method, hence deceptively simple. The things that we can do with it are quite remarkable, however. Just to give you a sense of how diversely applied the free list method is, you can see some recent examples. Renatus Bernunas asked about this sort of indigenous concept of setkel in Mongolia. So he said, please list all of the things that you think of that you associate with this concept of setkel. So participants listed all of these items, and he was able to cultivate or develop a cultural model around what this interesting concept is. People in the United States have asked what honesty means. So again, this taps into this idea of what various concepts or high inference constructs refer to. getting a list of the kinds of meats that people eat in Cameroon, the kinds of things that happen to people, or the kinds of things that people believe will happen to them after they die, knowledge of wild mushrooms in China, and various ritual postures in Mauritius. All these wildly different domains that people are interested in studying. And sort of first task of ethnography is making sense of what people say or what people think or how people feel in these domains that they're interested in. This is all fairly academic, but there's sort of like applied utilities as well. So this idea that if culture it plays a big role in our lives, in human lives, chances are we have to intervene on some cultural things in order to make a difference in the world. So some have studied, for example, models of healthy and unhealthy foods in Brazil and Germany. This comparative study of what it means to be a healthy person, the kinds of things to avoid. Sunahara et al. Did a mental health alignment study in Japan where they interviewed patients and examined their cultural models and saw cases where they needed to intervene, where their models needed to be closer to what doctors were actually telling them. So it's a way to improve cultural homogeneity in a mental health context. Other examples in terms of applying free lists to make a difference are examining entrepreneurial strategies, cultural models of sexual consent, and the kinds of things that people that are salient in Ecuadorian communities that affect their lives negatively. So again, to the extent that culture matters to people's lives, these are wonderful case studies where the free list method is a way to understand the cultural model that matters in folks' lives, and then examining the kinds of things that we would need to intervene on in the event of wanting to do something about wide range of problems in these communities. So that's just a recent sample of different types of applications here. Some of the benefits of doing this, again, if we're interested in culture, we think culture matters, this is cultural data. To the extent that this stuff is socially transmitted, it really does sort of allow people to empty their heads in terms of the kind of information that has been transmitted to them and stored therein. Using free list, once you've collected it, you really get to know how people think, what people think. It's arguably not as in depth as other methods, so there are some limitations. But in terms of getting a sense of what people know in the domain, it's hard to imagine a better method for obtaining this information without other extant instruments. As we'll see, the free list data has cognitive properties, so we can link cognition and culture together in an elegant way. If we use free list data to measure, for example, how much people know about their religious tradition, for example, and you want to design a more precise scale of the kinds of things that people do and don't do, this really can maximize ecological validity of downstream precise methods. It makes them culturally relevant by learning about the culture first and then designing quantitative scales around that afterwards. The nice thing, as we saw in those topics, the free list can work with abstract domains, like what it means, what setkel is, or what honesty means, and more concrete domains, like how many animals you know, or the kinds of things that you think about when you're engaging in some practice. So a very wide range of concreteness in these domains as well. As mentioned already, they can be quite useful in applications. When we can intervene on culture, we can improve the lives of other people. One nice thing too is this is really easy to execute. Participants also tend to like answering them. You take what they say seriously by asking them these questions, as opposed to the relatively more impersonal act of having them circle a survey, circle numbers on a survey, for example. So it's much more direct way of soliciting information from people. As I mentioned too before, in terms of prediction, the value of taking this kind of cultural data and linking it to other data, it actually is easily linked to other data, other kinds of data, but it's rarely done. So a simple example would be if you're interested in how a culture might change across the ages, across age groups, you can easily make age a predictor variable here. And use age to predict the content and structure of beliefs. But this kind of thing is rarely done. For various reasons. And so the second chunk of this talk will be sort of pointing out examples of how we can actually do this in a predictive statistical framework. Some downsides of free listing, of course, is that once you have data and people's knowledge and lists, sometimes you have to clean it and code it, meaning that sometimes people might say the same thing multiple times, or say or list things that are not as different as they don't appear as different as you might think they are, and it does take some time cleaning and coding. If you are interested in a particular domain and you have a theory that guides what the kinds of things that people ought to say, that can help expedite some of this. But again, the nice thing about actually sitting down and cleaning data like this is that you really do get to know what people are likely to say, and you can sort of infer what the cultural models are going to emerge once you get the data cleaned up. One sort of downside potentially is that some actually deny cultural information is very important in human behavior. Some think that it's actually quite trivial. So for various theoretical reasons, some folks might say, well, this is all good and cultural information is all nice, but it doesn't really affect our psychology in any deep way, or affect others in any sort of deep way. I think the proof is in the pudding, but we'll talk about some of those examples as well. The method appears quaint because it's so simple. And again, I think this is sort of lost on a lot of studies where we get this rich ethnographic data, but a lot of stuff that could be applied to it simply isn't. And so talk sort of sets out a way that you can sort of expand the kinds of questions you can ask with decent answers as it pertains to this data. Some of the problems before the past few years is that there were problems of very little critical mass. So there was a sort of esoteric software that required a DOS emulator in order to use it. Some of us developed package software anthro tools to be able to handle this data more efficiently. The nice thing is that that's expedited and facilitated all sorts of analyses as well in recent years. So I think the problems of critical mass might still be the case, is that there's very little, given the amount of free list data that's in use around the social sciences, using the software that can make it even easier is less appreciated. So this is software as a way to overcome previous practical limitations. All right, so let's get on with the actual free list data. So this chunk will talk about content analysis. So some basic steps that you can do to assess this kind of data, right? So as I mentioned before, the bare minimum information you need when you collect free list data is who says what they say, and the order in which they list it. So again, this is the same thing where if we're interested in the kinds of animals that people are aware of, we just need to ask, list all the animals you can think of, and then people will list it. We need to keep track of the order in which people list it, and we need to keep track of who listed it. That's the bare minimum. All sorts of other things you can attach to this. Talk about one example, but this is the bare minimum you need to do quite a bit, right? So just based on this, we can examine the frequency distribution of the kinds of things that people list. So this is from a free list that I did in my field site in the Tuva Republic of Southern Siberia. So I asked people what it meant to be a good person in their context. And you can see here across the x-axis are just the kinds of things that people listed. And this is the raw numbers of how many people in the sample, of about 85. who listed what. So you can see here that hardworking was the most frequently listed item in what it means to be a good person. Helpful is a close second, respectful, modest, kind, etc., etc. So you can see here with these singletons down here is kinds of things that people listed in a one-off fashion. You can see here where there is a kind of nice concentration of commonly listed things in here. So right off the bat, once we have a sense of what people say and how frequently they say it, we can get a sense of the frequency distribution of cultural models, or the kinds of things that people will list. We can take this data and then calculate what's called item salience. There are a couple different ways to do this, probably the most common standard way. We can get item salience, where it's just a way to scale each item from a value that maxes at 1. So every first listed item that people list gets an item salience score of 1. The calculation simply is, right, here's the number of items that people list, plus 1, minus the order in which they listed the item, divided by the number of items they listed. So you can see here, it's probably easier to see where this person listed 4 items. The first thing they listed was goat, and that gets an item salience of 1. Sheep gets 0.75, yak gets 0.5, 4 gets 0.25, and so forth. There really isn't a way to scale the salience. If you can think of this index as salience from a memory, in a context of memory, it's the most accessible item. So this individual thought of sheep first, and goat, and then yak, and you can quantify the accessibility of these items in their animal domain. So each item gets its own salience score. Now, cultural salience is the sum of all of these item salience scores divided by the total sample size, so the total number of people who did the free list task in the first place. And so then you can get a sense of how common and accessible certain items are. So then you are already sort of getting a sense of how cognition and culture work together. This is the cultural salience, or Smith's S score, that's commonly used. Again, there are other metrics for this as well, but this is the most common one. So show you an example of a more abstract concept. So I live in Denmark, and if you look at the tourist information, the Danes seem to be obsessed with this concept of hygge. And the other countries have similar concepts, whether it's the Dutch, German gezellig, or English coziness. There's certain elements to what it means to achieve hygge. But usually, if people will say this was a very hyggelig experience, and they'll use this term. But of course, none of the tourist information or your friends really help you out when you're trying to learn what this means. They don't empty their definitions onto you. So did a simple free list task of what it means to Danes, what hygge means to Danes. And then you can see here that when we analyze this and calculate the cultural salience of various elements of the kinds of things that people list, you can start to get a sense of what Danes think of what this mysterious hygge concept means. See here that candles have a cultural salience of 0.75, it being dark out, salience of 0.57, family of 0.56, and so forth. So you go around this flower plot, you can see that the sort of accessibility weights change as a function of these Smith's S values. So this tells you something about the cultural model of what it means to, or what hygge means. And again, just to remind, is that this salience score, the bigger it is, the higher it is on people's lists, and the more culturally ubiquitous it is, meaning the more widespread these elements are. So candles and dark out and family and warmth and friends and tea and music and just the sort of relationships that we have in sort of cozy contexts, this is part of the model of what it means to be hygge, or how to fulfill hygge in a Danish context. Just to show you how sort of interesting these properties are, is you can take the average item salience, that's this x-axis here, the average item salience, and regress that on the percent of the sample who listed an item, and there's a positive relationship. Once again, what that suggests is that the accessibility of particular items in individual minds corresponds with how many other minds in their community are also going to list it, suggesting that this cultural salience score really does sort of encapsulate important elements of culture in terms of its ubiquity, but also cognition and psychology, accessibility or psychological salience of items. So these are kind of two important aspects of the same general metric here. Now, it's not, Smith's S and other metrics like it aren't just limited to cultural information, right? So here's an example from Yoon et al. It was a marketing study where they had 6 different samples of coffee, and they had participants taste coffee and then say, list all of the features of this coffee that you can think of. And across these 5 things that people wound up listing, you can see here that the sweet flavor of, what is this, sample 5, or is it sample 2? Sample 2, I think. The sweet flavor is the most salient item listed in the free lists of how people responded to this particular kind of coffee. So if you're looking for a really sweet coffee, this might be the one you wind up pushing as part of your campaign strategy, for example. The point I'm trying to make here is that this is about individual perception of taste of the same stimuli. It's not that the participants are culturally transmitting these particular properties to each other, but rather they're using cultural information as a way to describe incoming things like coffee flavors. So Smith's S can be useful as well to talk about individual level properties of perception and taste, given that there is some conformity across samples. Here's an example of how we can start examining subcultural variation as well. So we've got Hugh Turpin's data from Ireland, where we have 2 different samples who have self-identified as being Catholic believers, and then those who have abandoned the church for various reasons. And you can examine that within a population, a single population, how certain subcultural characteristics can emerge. This is an intuitive example, as we can see here, where the cultural salience of listing abuse, corrupt, authoritarian, outdated, and dishonest when participants are asked to describe the church. You can see how believers are these are much less salient or culturally salient items in the lists of believers. Whereas you can see those who have rejected the church, these are the kinds of things that come to mind quicker and more frequently amongst apostates. So here's an intuitive example of how we can examine how there's going to be subcultural variation within a sample using Smith's S as a nice index or metric of that, or giving us a hint of that variation. That sort of leads to various things we can do in terms of examining the structure of cultural content in these cultural models. So there are a wide range of ways to do this, but there are some common steps in what might be called structural analysis. One is that you need to turn your free list data into what's called a feature matrix that includes the target properties of what you're interested in. This can be a matrix of whether or not people in your sample listed particular items. You have a matrix of the order in which people listed their items, this item salience of items, and so forth. Whatever aspect of free list data that you're interested in, this is what you need to at least turn it into first before you start examining the structure of the things that people list. You then take that feature matrix and turn that into a relational matrix, meaning you get a sense of the relatedness between items. So if it were a presence matrix where you just have participants by whether or not they listed specific items, the relationship matrix will be an index of the common co-occurrences across item types and so forth. Order, as we'll see in an example, the order is a relational matrix gets the average distance between item types and so on. So that's another step in the process of examining the structure of cultural information. Once you take that relational matrix, you perform what's called metric dimensional scaling or factor analysis on that matrix, and then you get a set of spatial coordinates so you can examine, again, like the almost literal structure of the items that people list. And finally, you want to analyze the output of that kind of analysis and plot the spatial coordinates that are a result of the scaling techniques. I'll show you some examples to show you how cool this kind of stuff can be once we start using them. And of course, interpretation plays a big role. I don't know if you guys can actually see that, but point 5 there is interpret the outputs is also an important step. As we'll see, these analyses will do what you tell them to, but they're not going to interpret the meaning of the outputs very well. So I'll show you some examples. So here's an illustration. Say we take, here's this a relational matrix of cities in the United States. You can see here how Chicago is 963 miles from Boston, DC is 429 miles from Boston, and so forth. So this is a symmetrical matrix of literal distances between the cities. So here's our relational matrix. As mentioned before, if we apply multidimensional scaling techniques, we can get coordinates across 2 dimensions or more if we want, 2 dimensions for each city. And what those are coordinates. And so when you plot those values right there, you get this lovely inverted map of the United States. So here's Seattle right here, Los Angeles right here, Miami, Boston, and so forth. The reason why it's upside down is simply because the analysis doesn't know which way is north. That's us. So you can easily just flip this matrix around and plot it more in line with what we intuitively recognize as north. The analysis itself doesn't know that. You can see here there are 2 dimensions, namely north, south, and east and west. And these coordinates are nicely spaced, and they're derived, again, from simple distances across each map. So this is what one form of structure analysis can do. Well, how can we do this, sir, and what can we get out of free list data? So here's an example of listing animals in southern Siberia. List all the animals that you frequently interact with or see. And here's the full data set. Again, participants, order number, and things that they list. Step 0 is getting your free list data. Step 1, once again, is getting a feature matrix. And so I'm going to show you here is just the order in which people listed them. So this is listed sheep. TV001 listed sheep first, goat second, yak third. TV002 listed sheep second, goat first, etc. So this is really exactly what this is in a simplified form. All right. So here's our feature matrix. We can create a relational matrix and use Euclidean distance as a way to measure the actual distance between each item. So here we're interested in examining the relationship between where people listed sheep and goat, for example, and sheep and yak, and sheep and cow, and sheep and camel, etc. So we can use Euclidean distance as a way to get the sum of all of these distances, square that value, and then get the square root of that to cancel out that squared value. So we're getting, if you think about these or appreciate these as the order number in which people listed things, these are literal distances between items listed in these lists. So you can think about them ultimately as allowing us to create coordinates of all of these items, right? And so here is our relational matrix. This is just a Euclidean distance matrix, and each value here tells you something about the distance between listed items, where sheep and goats, intuitively in this case, are this value is smaller, because if someone's going to think of a sheep, they tend to think of a goat. This is a herding example from, again, southern Siberia. So you can think of these are the common things that people interact with regularly because that's what their livestock are. So here's our relational matrix. Now, I'm just going to have to appeal to the magic of linear algebra here, but this multidimensional scaling, as I mentioned earlier, we can take that relational matrix, create coordinates from that, and then plot. And the last step is to interpret that. So we have coordinates here, and you can see here that sheep, goats, yaks, and cows are in a nice cluster here. These are the kinds of things that people have domesticated, right? These animals are the kinds of things that people might interact with less frequently, but they're more common than, say, interacting with a crane, a highly mobile bird. So you can see here, at least in this plot, it's not cities on a map, but rather it's animals in the conceptual structure of accessibility or familiarity amongst the sample. So again, slightly intuitive example, but you can see how in other domains this might be extremely useful to uncover new patterns. You can see here in this dendrogram, you can see how it's simply another way of plotting these dimensions. You can see how sheep and goat are highly related, but they're part of this domesticated animal structure, as foxes and cranes are far more distant from this, as are camels and snakes. Again, these are the kinds of things that people might be more inclined to see on a regular basis, whereas camels and snakes might be the kinds of things to avoid. So there are ways to interpret the dimensions and structure of these listed items, namely the structure of a cultural model. Here's an example from kids' models of the natural world, their knowledge of the natural world in Pemba. And so we've got kids listing animals and plants and the kinds of things that they list and running the same kind of structure analysis on them. You can see how the kids are, at first approximation, dividing on this first dimension here, dividing the animals and plants that they know into exactly that, animals and plants. So they're making a distinction. They're accessing chickens, cows, doves, and goats. When one lists a chicken, they are likely to list cow and dove and goat, and more likely to list them together. There's animal cluster that they're accessing. Then they also move on to plants. When they start listing plants, they will list these exploitable resources, the things that they go find in the forest. I'm not entirely sure how to interpret this particular dimension, but it strikes me as guavas, mangoes, and lychees are the kinds of things that are easy to go and get and just eat right off the plant. Coconuts and jackfruits take a little bit more work. So you think of effortful accessibility here, whereas this dimension is animals and plants, or animals and exploitable fruits, and this dimension, the vertical dimension, is accessibility. And these are all resting on zeros, likely because they're unaffected by this particular dimension of accessibility. That's just one interpretation, but you can see, once again, the structure of the children's Pemba kids' worldviews here has some logic to it, with animals being in one family and fruits being in another. So again, we can apply the same principles to color perception data. You can ask people to list all of the colors that they can think of, and cross-culturally, we find very similar results. Here's an example where all of the core colors get clustered together, so blue, red, green, yellow, and then you can start seeing mixed colors as this structure fades out. You can see achromatic colors like beige emerge as well. Again, once again, you can see the structure here of core colors, sort of primary, but secondary mixtures, The achromatic colors of black and white here, they're achromatic, beige, gray, brown, and so forth. So again, there's color perception or color classification data across cultures can tell us something about how people think of the relationships between colors as well. Using what's various techniques called network analysis, we can turn free list data into a conceptual network so we can examine like the core of a cultural model. So once again, taking this data from Southern Siberia of what it means to be a good person, same stuff we saw before, so hardworking, helpful, respectful, and just taking this and turning it into a presence or absence matrix, and then examining what the semantic network looks like, we can see this, where we have, these are all the results, and each line here is a connection of co-occurrence between these items. You can see here the structure of these models often look this way, is that you have a core model. Like you can argue that this is the essence of what it means to be a good person in this sample, like it is the core of their cultural model, with more peripheral items less frequently utilized, and the extreme peripheral items infrequently used, or making only a few connections across items. So here you can think of as often as we tend to think about, the cultural core of certain items or certain institutions or certain belief sets. This is a nice way of quantifying and visualizing what that metaphor actually means. Here's an example drawing from free list data collected in Western British Columbia, Vancouver Island, I believe, where you have First Nations, Indigenous people listing animals in their community, and non-Indigenous individuals listing animals in the community. This particular implementation of free list added sort of a successive component to it. They had participants list all the animals that they knew, and then they had popsicle sticks that had an arrow on it that said, "This eats this." And so they treated that as a successive free list, where they said, now apply these arrows to as many relationships as you can. So they generated indices of free listed items, but also the salience of trophic relationships. And then we can use network analysis to examine cross-cultural, cross-group differences. You can see here how in the non-Indigenous sample, humans are more centrally located in the network. Bears play a huge role, and what links bears and these other seafood are humans' predation on bears. In the Indigenous, amongst the Indigenous sample, humans are actually not central to the main network, according to this analysis. Rather, they're quite peripheral. Bears are also central, but sea otters play a huge role in the ecosystem, or the worldview of the ecosystem amongst the First Nations people there. So here's another example of how we can use free lists and link it to other techniques in order to examine variation in how we interact with the world. So that's a brief sort of guided tour of structure. Here's a little bit on overlap and variation. So if we can measure a cultural model of one domain, we can examine the relationship between multiple domains. So here's a fun example of where we asked people what makes gods angry in their community. And these moralistic gods were pre-selected on the basis of, namely, how concerned with morality they were. And I use that in quotes. We had a precise definition. For all intents and purposes here, it is behaviors that impose a cost on others, interpersonal behaviors that impose a cost on others. So you can see how the moralistic gods, typically the god of Christianity or Hinduism, these gods are across a variety of possible codes. These gods primarily care, and these are different groups around the world, primarily care about moral stuff, What angers gods is being immoral and lacking virtue. Now, when we ask the same questions and use the same coding scheme across what local gods are, and local here just means another significant deity that is not necessarily as concerned with morality as the other one, we see cross-culturally there's far more variation in the local gods. These local gods care about just different things cross-culturally. So they're not as obviously concerned about morality and virtue as the moralistic gods. Big surprise there. What's kind of fun about this is that we ask people the same question about the police. And unsurprisingly, perhaps, they really do resemble moralistic gods in terms of their concerns with morality and virtue. Cops are a little bit more concerned with drugs than the moralistic gods, perhaps unsurprisingly. But the idea is that we've got three different domains here. We can quantify the conceptual overlap between these domains, and it should be intuitive that this domain, the moralistic gods, is going to have much more overlap with the police than, say, the local gods or the police and the local gods. And we can use Jacquard similarity to measure this. So this is a result from just one field site. And you can see how here in my field site where the Buddha is conceived of as a god, there's considerably more overlap with what angers Buddha as with what angers the police than what angers local spirits. Pick up the pace here. Cultural FST is a metric that was devised and inspired by a biological FST. It's really just a way to make a scaled metric of where variation exists. So this can skip the math, but the idea is that when cultural FST approximates 1, all of the variation that you're accounting for exists between groups, whereas if it's 0, it exists within groups. So it's a metric of cultural diversity within and across populations. And once again, using a kind of structural analysis, you can examine where variation lies in any kind of cross-cultural assessments you're interested in making. All right. So again, we can take the similar principles going back to the data from Turpin, and we can examine how much homogeneity there is within these two subgroups. So you can see here, once we apply a structural analysis to the free list data of believers and apostates in Catholic Ireland, you can see here when people reject the church, this white density distribution here, there's far more variation in the likelihood of listing these things amongst apostates, whereas the salience of listing these things is pretty homogeneous amongst the actual believers. So it's clearly suggests there's both homogeneity in responses, but also with this intuitive example, it's likely that there's going to be more homogeneity amongst the churchgoers by virtue of their commitment to the church. And the last chunk is about prediction. So given this data, we can port features of free list data into a predictive statistical framework. So we can make statistical predictions about the order in which specific items are listed. So here's an example of the order of listing those items in a statistical framework with the Catholic and ex-Catholic data. So we have the statistical techniques in order to actually make predictions about when people will list specific items, which is quite underutilized in the field. Here's an example from Koster et al., where they collected free list data about knowledge of fishing, and then they had community members make recommendations of who are the best fishers according to various techniques. And it turns out that there's a positive relationship between how knowledgeable people were and how many people in the community endorsed them for being successful hunters. But that goes for 2 particular hunting techniques as opposed to one of them. And there are interpretations abound. But the idea in here is that the breadth of knowledge can predict expertise in behavior as well. Here's an example where people participated in a behavioral economic experiment where they got ripped off. And they were asked to basically make a risky, trusting investment in another Christian. And a sample of the experiment got ripped off from these other Christians. And it turns out that when that happened, their models of what angers God were more likely to include things like greed and selfishness than a sample of Christians who were not ripped off. So here is a case where an economic exchange can, at least temporarily, affect the cultural models that we express. We can also use the flip side where we can examine cultural models and examine the likelihood of cooperating with others as well. There seems to be some traction there, suggesting, unsurprisingly, perhaps, that our values actually matter. This idea that what we know can have an impact on our behavior, and free list data can be used in this fashion, is also been demonstrated to some success. And finally, this idea that these Likert scales and free lists have different properties or important differences is that recent studies show that we can make predictions about what people list, and we have prefabricated scales that are designed to sort of tap into it. There seems to be very little corresponding to these items in this particular problem. But this idea that we can use conceptual salience and predict conceptual salience strikes me as an advance in the field of cultural psychology, and that we can, if we want to understand someone's domain and the structure of that domain, we can use various predictors to examine that question. In this particular context, we were interested in the salience of the kinds of things that people list that their gods care about, but the scale didn't actually predict much of what was stated, suggesting that cultural models are not tapping into the same thing as a Likert scale. So same cognitive process is probably ruled out here. Given all this, the ongoing efforts that we've been working on is giving us a better sense of what is going into the data generation process. Like, what are the psychological processes and practical processes that go into accounting for or creating variation in the data that we collect. Having a better sense of the data generation process, of course, will give us or lend itself to better inferences about causation as well. So if we can intervene on particular variables that matter in affecting salience or frequency of listing, for example, then we'll be able to establish better causal models of the evolution of culture. And given that, the current project that I'm working on is examining the longitudinal evolution of cultural models with explicit interventions. So much like that example I showed where cultural models can change as a result of an economic impact, we've got repeated measures of free list data to examine the evolution of cultural models given particular interventions. And that will also allow us to come to better terms with the causal forces that go into culture change. And I don't think I could have timed that better. That was the alarm just went off. So thank you very much.
So thank you for the interesting and illustrative presentation. And now it's time to open the discussion. So if anyone has any questions, please do not hesitate to ask. And the first is Roman Purzycki. So please.
I'm sorry, that wasn't a question. My colleague just wanted to express the clapping notion through the emoji. But thank you for the talk. It was very interesting.
Thank you.
And maybe I would have a question actually. It seems like the thing you talk about, it works with a data set that has a limited possibilities. So imagine if I ask some more general question to which there could be many more possible answers, it wouldn't be so providing as to the information that it gives us. Is that true? Or?
So To be perfectly honest, I have not compared across domains in the way that I think you're hinting at. So this idea that if we ask people what it means to be a good person, that's very fluid, that's very open, right? And so there are metrics that can tell us how concentrated and how sort of diffuse and open these domains are. The difficulty here is that the comparison between, let's say, what it means to be a good person and how many animals people know, those tend to be more discrete, right? Within a single sample, you can come up with a metric of what's tighter and what's a looser domain, right? But you can imagine cross-culturally, that metric's not going to necessarily be the case across all domains, so across groups, right? So I don't think there's any single metric that we can yet, maybe I'm wrong here, but I don't know of any single metric that can be reliably used to say that domain is going to be 0.5 in terms of fluidity or open-endedness, and that domain is going to be more concrete, for example. So you can compare within samples, and so you saw the hardworking, or what it means to be a good person, right? The salient scores tend to be a little lower on average for these more fluid and open-ended kinds of things. But you can also adjust that by truncating the number of items that people list. So if you say just list the top 5 things, then you're bringing it a little bit more on an even playing field. So there are a few moving parts here to answer the question, and I don't think there's a general way to go about doing it without really being careful about cross-group variation, how you answer the question, and so forth. And so but it does open up the kind of important question is like, why would animals be a tighter or more homogenous cultural model than, say, what it means to be a good person? Is it something about the nature of that domain? Is it about the nature of how these things are transmitted? Is it, I'm not sure, but it does, like, these questions are out there and they're important. Yeah.
Okay, thank you very much.
Yeah.
Okay, thank you too. And the next one is Martin Palachek.
Hi, Ben. Thank you for your great talk. And I do have a question. It seems to me that this method is focused more. No, I put it in other way. How is there anything how to avoid that people will tell you only what's acceptable for them or
Yeah.
desirable?
Yeah. A lot of that's gonna depend on the domain, right? So, like, I don't know what it means to list a desirable animal for, so like there's some domains where the concern is not necessarily a huge issue. The interesting thing about this, and this is where I think there's promise in it, but not enough work done on this particular kind of question. So if you say, well, what does it mean to be a good person, right? They're really going to tell you what they think is going to be good and what they think you might want to hear. But we know that this answering varies across groups, right? So there's still differences or variation to answer, right? But one way of minimizing that concern is examining how free list data relates to other important variables that might indicate the same kind of thing, right? So, I mean, one way to test that I ask people, like, what makes God upset? Well, if you intervene with an economic experiment and there's a different outcome in the game, then you can see that their cultural models are likely to change, right? So they still might be a class of information, like they're telling you what they think you want to hear or whatever, but it still changes as a result of something else. So, like, it's still sensitive to outside inputs, but I think the best way to go about doing that is to minimize that concern, is to examine its relationship to other metrics in an intuitive way. So I'll push this point a little bit harder, and so that the thing that Ty Spen Dixon and I had worked on, where we examined, we said, what makes your gods upset? And then we asked them questions about how much does your God care about murder? How much does your God care about theft? And how much does your God care about deceit? And so whenever people listed those items, we examined the relationship between that scale to see if there was any correspondence. And there really wasn't. Right. And so that led us to conclude, or at least, ponder the likelihood that these things aren't stemming from the same process. In other words, it's not just people saying or answering in such a way that they want to be associated with, but rather these are two metrics that should have corresponded together, but rather the process that they're a reflection of is one of either cultural memory versus individual reasoning about how to answer on a scale, like a quantitative scale, right? So if there are two different processes that work, it's not the same underlying motivation that might be the case. But getting these participant effects of like wanting to seem more X or Y, whatever your domain is not inherently avoided by this method. I think that's definitely true.
Thank you.
Okay, thank you. Any other question or follow-up?